In this lab, you will open the simulation and construct an RLC circuit using the provided diagram in the lab write-up as a guide. You can get the numerical values of each element by right-clicking on each. The voltage chart can be used to complete the data tables once the switch is closed. You will complete this part of the lab for 2 different voltage frequencies as indicated in the procedure. In the second part, you will use your setup and measure the voltage drop across the resistor while changing the frequency. You will want to step through the frequency values in 0.1 Hz intervals until Table 2 is completed. Excel can help with some of the calculations. Here you can see how I set it up to get the percentage error values between the capacitor reactance values from the experiment and the theoretical values for a given capacitance and angular frequency, 2π multiplied by the frequency, as well as the percentage error values between the inductive reactance values from the experiment and the theoretical values for a given inductance and angular frequency. The equations for the theoretical values for both the inductive reactance and the capacitor reactance are found in the theory portion of the lab write-up. Much of the terminology for an RLC circuit is found in Chapter 21.5 in a textbook. Example 21.4 goes through some of the same calculations you are asked to do here. You might find some of this to be helpful. You are also asked to go through an alternative process for finding the inductive reactance. This might better be done on a calculations page because of the way you have to manipulate the equations given rather than having Excel to do it. If you can find a final version of the equation in terms of the data cells, you're welcome to put it in Excel, but it may be just as fast to get that final equation and put the data in it by yourself. As to the graph, you want your frequency on the x-axis, so list it in column A. List your voltage in column B. The graph should not be linear, but should show some sort of peak if done correctly. To fit the data, once you have expanded it as in past graphs to what should be close to a full page, choose Insert, then Chart, then Scatter Plot, then Connected Dots. You should produce a smooth curve through the data. Find the peak and project its location down onto the frequency axis. It might be easier to do this if you click on your graph and choose Chart Design. Under Chart Styles, you may find some of those that will put grid lines on your graph. Knowing which block holds the frequency below the peak can help you to better identify the value of the peak frequency. The write-up gives the formula for the peak frequency for a given capacitance and inductance value, allowing you to get a percentage error between the graph value and that theoretical value. What you will submit. In addition to the completed data tables and answered questions, there should be a calculations page with all calculations asked for. If you have Excel do some of these for you, simply copy your Excel data table into the calculations page. You might use the grid function under font to put solid lines around each of your cells of your table to make it clearer. After that, on its own page should be the graph properly labeled and titled Filling its Page.